Hello friends, in this video I'd like to solve the following problem from the Spanish Mathematical Olympiad, final round 1984, problem number 4. We wish to evaluate the following infinite product in fact, from k equals 1 to infinity of cosine of x over 2 to the power of k. So in other words, it's cosine of x over 2 times cosine of x over 4 times cosine of x over 8 and so on up to infinity. My hints are the following. The crucial is the formula for sine of double angle. Sine of 2 times alpha is 2 times cosine of alpha, sine of alpha. And the second well-known fact is that the limit as alpha goes to 0 of sine of alpha over alpha equals 1. So give this problem a try and see you in a minute. Okay, so I hope that you tried your best. First of all, infinite product from 1 up to infinity of cosine of x over 2 to the power of k, it's by definition the limit as n goes to infinity of product from k equals 1 to n of cosine of x over 2 to the power of k. And now we will try to simplify this finite product. So I will write it maybe without using capital sigma notation. So I will have cosine of x over 2, cosine of x over 4, and so on, cosine of x over 2 to the power n minus 1, cosine of x over 2 to the power of n. And the trick is now to multiply this product by 2 to the power of n sine x to the power 2, x over 2 to the power of n. Why? So after this multiplication, we can transform our product to get the following. Maybe write the crucial part in yellow. Cosine of x over 2 to the power of n. Here I will take 2 ones. I will have sine of x 2 to the power of n, and remaining is 2 to the power n minus 1. And now this part which was written in yellow, by the formula for sine of double angle, it becomes sine of twice the angle, but 2 times x over 2 to the n is x to the power 2n minus 1. And instead of 2 to the power n minus 1, I will write 2 times 2 to the n minus 2. And here, again, the same formula can be used. So I will have cosine of x over 2, cosine of x over 4, and so on. Here I will have the term before this underlined expression will be x cosine of x 2 to the power n minus 2. Then we will have sine of x over 2 to the power n minus 2, 2 to the power n minus 2. And again, I can do the same trick over and over again, and it's pretty easy to see that after many applications of this formula, finally I will have cosine of x over 2 sine of x over 2 times 2. And finally, I will arrive at sine of x. So this product right here is just sine of x. So in other words, Now by dividing by the expression written in green, we can deduce that cosine of x over 2, cosine of x over 4, and so on, cosine of x over 2 to the power of n, after division, it becomes sine of x over 2 to the power of n sine of x to the x over 2 to the power of n. Okay, so now our infinite product is just the limit as n goes to infinity of sine of x over 2 to the power of n sine of x over 2 to the power of n. Okay, and now I will do one trick. I will write this as sine of x over x times x over 2 to the power of n sine of x over 2 to the power of n. And now let's look. First part is constant. It's not dependent on n. And what's the second part? Using this well-known fact that sine of t over t goes to 1 as t goes to 0, this as n becomes large, so this goes to 0, this goes to 0 as well, so we have exactly something like alpha over sine of alpha, where alpha goes to 0 or t goes to 0. So the second part is just 1. So we get sine of x over x. Of course, if x is not 0, because for x equals 0, we had division by 0 and it's a problem. Okay, so we have to consider the case of x equals 0 separately, but it's pretty easy. If x equals 0, then our infinite product will have just a bunch of cosines of 0, and cosine of 0 is 1. So we'll have 1 times 1 times 1 and so on, and it's 1. So we have now reached our goal, our formula. So the product from k equals 1 to infinity of cosine of x over 2 to the power of k is sine of x over x if x is non-zero, and it's 1 if x in fact is 0. And that closes our problem. So thank you for watching. I hope that you learned something new, and see you soon.